Hello, welcome to LeetCode Solver. Today we are going to solve first problem in May LeetCoding challenge, and the problem name is first bad version. First bad version. You are a product manager and currently leading a team to develop a new product. Okay. Unfortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version, all the versions after a bad version are also bad. Yeah, true. Suppose you have n versions, 1, 2, n. You want to find out the first bad one, which causes all the following ones to be bad. Yes, once like x become bad, then x plus 1, x plus 2 up to n will become bad. You are given an API bool is bad version which allows return whether version is bad. Okay, we will have one API which will return if I provide version like X, it will tell me whether it is a bad one or not bad one. Implement a function to find the first bad version. You should minimize the number of calls to the API. Okay, well, so is there anywhere mentioned that there will be bad version for sure? Bad version always exist or not? Well, latest version you are given latest version fails the quality change. Okay, it is written the latest version of your product fails the quality check. That means nth version fails the quality check. So nth version is bad version, but we have to find the one which was bad earlier than n. N will be bad for sure, but we have to find the one which was earlier. Bad one, which causes all the following ones to be bad. Well, so if this is the case, then we see a pattern over here, like the last versions are bad. So for bad version, we can say uh, 1, 1, 1, 1. So if the software versions are started from 1, 2, 3, 4, 5, 6, 6 is n, then this is a bad version. So let's represent bad version as a 1. Then we see here this is a bad version and we can assume first three are good version. So this is good version and this is a good version. So bad version, these are the bad version. So is bad version, the API available will return true for these. If we pass 4, it will return true. If we pass 5, it will return true. If we pass 6, it will return true. This is an example. Example. Let's consider something like this example. So what we see here is like after a certain time, the all the elements will be, all the versions will be bad. So before certain time, all the versions are not bad. Well, so in order to find the bad version, we can we have to go to the right side. I mean, if we divide the given array to the half and try to find like there exists a binary search property actually. So that if we partition these whole things and say we are at, if we partition whole things, then we will be at this position. This is as a mid, and we see that mid position is 1. That means this one is bad, and all the elements before this was already bad, should be bad by the property, uh, by the property of that exists um, in the given problem statement. So all the elements to the right side should always be bad if one element is bad. So we don't have to look at the right side, right half of the binary search partition. So we can easily filter out one partition. If we divide the whole partition to the mid here, then we can certainly say that this half is not necessary at all. So because this half always contains bad version. Now we will try to move to the left side and see if there any bad version exist or not. If there exists a bad version, then these will be the answer. Otherwise, the one that we found in the mid, which already contained one, will be the answer. So we will go to the left side and do the same thing. We'll go to the left side again. We will divide the half into two half, and we see there is a 0 available. So we should not go to the left side. Now this half will be now we see that this half, the left half will not be taken, because we see this mid is a 0, and if this mid is a 0, then we are sure that all the elements to the left side will definitely be 0. So in every step we can easily eliminate one half. So if we can eliminate one half, then we are good with our binary search. So here we will go to the this side, and again in this side we find nothing, like there is no any zeros. So ultimately whatever we found before was our answer. So in this way we will proceed. So as we are doing binary search over here, the complexity of the solution will be, let's consider time complexity. Time complexity would be uh, big O of log n, where um, why log n? Because every time we are just dividing our array into half. So and then after, again we are dividing half. In this way we will reach to the complexity of big O of log n. So I already explained one problem before, why we come up with log n. I mean why we calculate this thing. So for that you can check out the previous video. And for now let's consider the space complexity. Space complexity would be constant, because we are not using any extra space. So let's go with the binary search. We will define the both uh, the range of the boundary that we are interested for binary search. The boundary will be starting from 1 to high will be, low boundary will be 1, high boundary will be n. In this range we will be doing binary search. Now let's define our first bad version. So let's define answer easily. So answer like first bad version, say or answer or first bad version. Okay, first bad version, say first bad version is n. We are sure that if we do not find anything, n will be our answer, but we'll try to minimize this, minimize minimize first bad version as much as possible. So let's do a binary search until this condition meets, and in every step we will find the mid, and this will be the integer. So n can be egb is largest integer, so we can say we can, in order to avoid overflow, we can do we can calculate the half in between low and high by just subtracting high minus low by 2. We will get the half partition of the total range. But in order to calculate the actual value, we have to do addition with low. So in this way we can calculate the mid. And let's say if we have to give call to the isBadVersion API. So isBadVersion of mid, if it returns true, so this is bad. If it is a bad, we know that we have to try to uh, first 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 bad version, we have to try to minimize first bad version as much as possible. So minimum of already exist first bad version and mid value. And now we will minimize our half into one half. So we have now two half, low to mid minus 1 and mid plus 1 to high. So let's uh, change our boundary. Let's decrease our higher boundary. So we will decrease our higher boundary and move to the left half, because right half will always contain bad version. So let's move to the left half. In order to move to the left half, we have to uh, change the right boundary, which is equal to high will be equal to mid minus 1. Otherwise, we will go to the right side. In order to go to the right side, we have to change the low value. So yes. Now, yes, finally we will return our answer as a return first bad version. First bad version. Well, let's see. We always try to minimize this one. Let's compile the code first of all. Run the code. Okay. Let's submit it. Then we'll see. Well, accepted. So let me go through the example. Any example over here? 4 is the first bad version. So given example, 4 is the first bad version. So there are 5 element and 4 is the first bad version. So how it works, let's see. So first of all, the elements are like 1 and 5, and first bad version is initially we initialize as a 5. So now we will find the mid will be equal to 1 plus 5 minus 1 by 2, which is equal to 1 plus 2. 4 by 2 is 2, so which is equal to 3. So index at 3. Well, we have mid is 3, so this one is 3. So we see that if bad version, so basically if 4 is the answer, then the API, so it is not under our control, so this is some external API that is provided to us, which is returning us uh, false. That's why we are moving, our answer is in the right side, so it is returning false. So we went here and we change our low value to, now low value will be updated to this is 3, right? So it should be 4 now, and our range is 4 to 5. So we are sure that before 4, like before mid, is the 1 is not bad version. So that's why every elements to the left side are not bad version. So as the problem says, if some version becomes bad in the software, then all the versions to the right will always be bad. So we don't need to care about left side. So we just want to the right side by changing our lower boundary to 4. And now the range is 4 to 5. Now we will find the mid in this range. So mid will be equal to 4 plus 5 minus 4 by 2. 5 minus 4 is 1, 1 by 2 is 0. So basically we will have 4 as a mid, and we will call to this API, and this API tells us that this is a bad version. So if we found the bad version, yes, now we will change our range, and also we optimize this one. First bad version was 5 before, now it will be 4. Minimum among 4 and 5 is 4. So well, now we'll update our high to mid minus 1, so which will be equal to mid is 4 minus 1, which is equal to 3. So let's change it to 3. So as we see that the low is greater than high, so this condition no more valid. So this for loop will be exited, and we will return the first bad version. So in this way the algorithm works. This binary search algorithm for this particular problem works. Well, thank you so much for watching this video. Hope it helps you, and if you have any comment or any suggestion or any different approach to this problem, please feel free to share. and hope I will create other videos as well, like for upcoming days in May coding challenge. I will try to complete all those 30 uh, challenges. I mean 31, I guess, for this May. Well, I'll try to complete all the challenge, and I will try to upload a video per day, uh, like before in LeetCode coding challenge. So yeah, feel free to subscribe and share. Yeah, see you in the next video.